Okay guys, last video for today, and I chose to do smaller videos so you guys are not overwhelmed with the long one. The last one has to do with the sample problems, and this is how you're gonna know how to do the assigned practice problems, the homework. And the homework is page 410, 9 through 22. And I know it's going to be a little bit harder to track homework, to submit homework. I totally understand that, but I'm relying on those of you who actually want to learn and who actually want to practice the tasks, because especially with trig identities, if the more you practice, the better you become at doing it correct. Okay. So the first problem says simplify the trig expression, and this is our first objective. It's not solving. We're going to simplify, which means this given, we're going to make it simpler. As you see, the result that I'm going to walk you through is sine x. So this is simpler than this whole form. So how do we do that? Or before I explain to you what I did here, I just want to remind you of an important rule. T multiplied by t squared equals t cubed. And this is an exponent rule. So 1 plus 2 equals 3. When we multiply, we add exponents. It applies to trig identities as well, any function. So sine multiplied by sine squared equaled sine cubed. As you notice, the input is the same. It did not change. So we only cube the function, which is sine. Sine x is a block altogether. Cannot separate those two. So when you look at this, what I did is I broke down the cube into a square and a power of 1. And now, why did I do that? And I just copied this down as is. The reason why I did that, so I can find what we call common factor. So GCF, common factor. So the sine x is a common factor now, and what I did, I have factored by sine x. So what's left from the first term is sine squared, and what's left from the second term is cosine squared. And why did I do that? Why is that helpful? Because look at this. What did I get here? I got the identity, the very famous one, the Pythagorean identity. And by the way, number 9 means I have used identity number 9. And this is what we're going to agree to do every time you use an identity. That's why on my remind, I asked you guys to number the identities when you copy them into your notebook. So this is identity number 9, which is cosine squared plus sine squared equals 1. So this is the one I have used right here. So inside the parentheses, I got sine squared plus cosine squared, and that equals 1 according to identity 9. So now 1 multiplied by sine is just sine x. And I simplified that from the top to this last one. So this is sample problem number 1. Sample problem number 2, you see it's looks a little bit more challenging. It's blurry, so I'm trying to get a better view of it. So it's secant plus 1, parentheses, secant minus 1. And that should remind you of a plus b into a minus b, which is a famous identity or special case, which equals a squared minus b squared. So for me, like, the important step is to recognize it's a plus b, a minus b, and that's what I did, and that's what you're going to be able to do later on the more you practice, over sine squared. This is the given, and the question is, again, to just simplify it, which means make it simpler. So I noticed a plus b, a minus b, so now I know it equals a squared minus b squared. So secant squared minus 1, because my a is secant, my b is 1. So secant squared minus 1 divided by sine squared. If I look at the list of identities that I have just covered, identity number 12 says secant squared. If we go back here, let's go back to identity 12. So 12 says 1 plus tan squared equals secant squared. But what if I had secant squared minus 1? What would that equal? If I know that 1 plus tan squared equals secant squared, then this simply another version of it. So secant squared minus 1. If I subtract 1 on each side, I would get tan squared. So tan squared is secant squared minus 1. So I'll go back to the problem right here, the sample problem. And secant squared minus 1 equals tan squared. Tan squared divided by sine squared. So tan is sine over cosine. And I have sine squared over 1. Now, KCF stands for keep, change, flip. So I'll keep the top, multiply, flip the bottom. And those cross out, I'll be left with 1 over cosine squared, which is secant squared. Now, some of you might say this sound very confusing. It might, because it's new. Again, the more you practice, the better you become at it. And one challenge with this is there's no rule that I could tell you, oh, do this now, do that now. Step 1 is this, step 2. There's basically no common steps with this. So, for example, you might ask me, how do I know that now I have to write tan as sine over cosine? I have no answer, but my answer is the more you practice, the more you know what to do. Plus, if you look on the bottom, you see sine squared. If you want to get rid of it, the only idea is to write the tan as sine over cosine. If you tell me why did I do this, because I recognized a plus b, a minus b. So again, there's no common rule, but there is a way to get better at this just by practicing. The last example might look the most scary. No, I'm sorry, not the last. The one before the last. Let's do the last one. That way we can get one out of the way. Cosine of negative x and minus cosine of x. We just said in the previous video that cosine is even. An even function means the cosine of a negative x and the cosine of x are the same. So if I subtract them, I get a 0. And we took the example of cosine of 60 and cosine of negative 60. We got half for both. So half minus half equals 0. This is the last one. Example 3 is the most challenging, I would say. And this is like a common step that you might use in multiple problems. That's why you will get used to it. We call it making a common denominator. So that's basically what you're doing. And just a reminder, I can remind you using an easy example. If we have half minus a third, you need to subtract those two fractions, you would find a common denominator. So you multiply this by 3 and this by 2. This is the process of finding a common denominator. When you multiply the bottom, you got to multiply the top. But this is not as friendly here because you're not multiplying by a 2 or by a 3, but you're multiplying by a trig function. So 1 minus sine, you're going to multiply it by cosine. Cosine, you're going to multiply it by 1 minus sine. Again, what we're doing is we're making a common denominator, as you see right here. So after we made the common denominator, we just said if we multiply the bottom, we got to multiply the top. So cosine multiplied by cosine is cosine squared. And sine multiplied by 1 minus sine is sine of x. And multiplied by negative sine squared. Now, we have to take care of that negative next to the fraction. A negative next to a fraction is similar to a negative next to a parentheses. So we distribute the negative. So negative sine x and negative by negative is plus sine squared. And you can see now how this identity 9 appears again. So cosine squared plus sine squared equals 1. This is where I got the 1 from. And a minus sign, I'll just copy it down. And this is my common denominator. I'll rewrite it. So now you can see that 1 minus sine and 1 minus sine cancel out nicely. And you're left with 1 over cosine, which is secant. So we simplified it. We want from, remember, our objective is to simplify, not to solve. So if you look at this, This is a subtraction of two fractions that include 1, 2, 3, 4 trig identities. I'm sorry, trig functions. You go back to secant x. So this whole mess equals secant x. And that was our objective for today. As you're doing your homework, feel free to send me text on remind. I'll be more than happy to answer. Just please be patient as I'm receiving so many texts.